Good morning, everyone. So the first panel, we have three communication, three very interesting. But the first, we don't have the first. It was a plot system and adaptation. They don't stay here. So we start what the first deciphering urban morphogenesis, morphospace perspective from Caio Cacholas, Dries Daems. I don't know what pronunciation it's correct. Fabiano Lemes, Ribeiro, Howard Davis, Vinicius, Moraes, Netto. And second communication, co-learning between research and practice in planning, addressing the physical form of the city for Mélice Dias, Vítor Oliveira. And finally, the third, can topography favor the competitiveness of pedestrian over car? From Nuno Gomes, Vítor Oliveira, Álvaro Costa, and Miguel Lopes. Certo? Correct? Okay. I have some questions, but maybe then your presentation interesting. So if you want start? Sure. Okay.
Can you actually see this? Okay, I hope this is visible. Good morning. I'm Vinicius Netto. I work with, as our moderator mentioned, a number of co-authors. And the subject here today is about morphogenesis, and a particular take on morphogenesis from Morphospace, the concept of Morphospace, which is a concept from biology. Is this working? I mean, in terms of capturing? Yeah, okay. So cities are everywhere, and they emerged in different regions of the world and at different periods of time independently. So I'll have to move really quickly over the slide. So I ask you, I'm sorry about that, and I would like to, suggest or refer you to the actual paper. So a key question here is, how did we get to cities, and what are the forces that led societies in different periods of time and regions to create cities? So this is usually approached through the lens of morphogenesis. Morphogenesis is another concept, important concept from biology, meaning the production or emergence of structures, say of cellular structures and tissues and organic systems. But when we get to urban studies, it has to do with the creation, of course, and formation of specific specialities of human settlements. So we have, I'll go quickly over an archaeological data, if you will, bringing hunter-gatherer societies from 8,000 years or 10,000 years ago with their specific configurations, as you can see. Jumping to a contemporary hunter-gatherer society, we have the Kyukuru in the Amazon, Brazilian Amazon. We have the Bororo also in the Amazon region with a really beautiful, these beautiful patterns of settlements, quite ordered, quite structured. If we again jump back in time and go to Çatalhöyük, and apologies for my pronunciation, a proto-city into present-day Turkey, an amazingly compact structure. As you can see, people had to go into their houses from the roofs. So this is a sort of a classic example of a proto-city. We have structures like that even nowadays, like working in present-day Libya, like this pre-Roman oasis called Gadames, or you have a completely different Roman city in present-day Algeria. We have Patayahta, an Inca city in present-day Peru. These amazing structures everywhere, you know, very different regions with completely, you know, their own structures. And you have Picayahta, a Wari city even earlier than the Inca, with actual streets and urban blocks, if you will, or proto-urban. And then we jump, you know, to present-day New York. You have these recognizable structures, and also you have, you know, another amazing example of urban morphology in Rocinha, an informal settlement in Rio. So we have quite a diverse set of examples here of the possibilities of urban form, right, over time. So one question that I'm trying to address in my approach is what can differentiate urban settlements from non-urban settlements? So if we go to the literature, I'll do this quickly. Urban economics mentions the a key role of agglomeration for an urban society to emerge with its complex division of labor, like growing specialization. So people are more mutually dependent on each other because you are more specialized than, let's say, in a hunter-gatherer society where the division of labor is more based on gender and age. So as societies change, it doesn't mean evolve in any specific way apart from functional change. Okay, I'm not saying that societies are one better than other. That's not the point. The point is at some societies which engage into a growing division of labor begins to produce densities and agglomeration. Urban economics will structure, you know, working as agglomeration. If you have endless possibilities of agglomeration, and we need to know more than that. We have an approach here. This is diffusion limited aggregation, where cells sort of randomly, you know, bump into each other and start to create dendritic structures, like as you can see in the simulation. And this would give some kind of structure there, and ending up with something like this. And the problem with this sort of structure is that this reminds a lot of a tree. And as Alexander would say, a city is not a tree, right? So even though this is all interesting as morphogenesis, it's still far from what a city is. We have these much more recent density-based models of densification in different patterns from sort of a more, you know, we can imagine this like sort of a broad metropolitan structures or polycentric structures or rural areas. So it is sort of how you model density with a sort of a cellular growth. So our approach is going to use Morphospace, which means the space of all possible configurations. Okay, this is a concept from biology. It began with Haup in 1966. And the key point is trying to understand the differences in morphologies between shells, right? So you have a sort of a quite different shapes of shells, and Haup was trying to understand how these differences emerge and how they relate to each other, and what possibilities of form actual shells don't fulfill or don't go into that direction. So creating this sort of cube there, as you can see, with certain properties, which are spatial properties to be sure. And then the thing is that all these examples, they fit into a certain region of this cube. And you have whole regions which are not explored in nature. You don't find them in nature for some reason, all right? The reasons can be discussed, but I cannot do that right now. In architecture, this approach has been explored by Stedman and Mitchell for architectural plans. You have this 2D morphospace of possible building plans, right? So what I'm going to propose is exploring the idea of morphospace for 2D configurations, cellular configurations, and you can have anything in that space, right? You can have any possible configuration there. Just obviously a few examples there, quite differently from each other, very abstract stuff like this, or something which reminds us of cities. So all of these are possible forms in what I call Morphospace 1. So, but the problem is throughout urban evolution in different regions, probably most possible configurations cannot be explored by human beings. We are not going to try every single configuration. We would need like probably trillions of years to explore that through human effort, and that's not what humans do, right? But we do visit some configurations, and that's what I'm trying to understand here. This clearly cannot work as a city. This cannot work as a city. This cannot work. You cannot move properly in these spaces, right? So they become an issue if that were to be cities. So we have n possible configurations, but which ones can be cities? Then we go back to Alexander again and remind of his concept of goodness of fit and misfit, okay? Between context and form. By context, you can mean pretty much probably anything. But what I mean here is that, yeah, if you have a growing division of labor in an increasingly complex society in functional terms, you probably need a lot of interaction. Agents have to move, have to exchange a lot because they all depend on each other for surviving. More and more, this process is ongoing. Therefore, you need a lot of mobility to reach places and cooperate with other people, right? This is covered in some literature, which the paper also mentions. And then you have urban form and density. So I'm approaching this as a relation between function, if you will, interaction and mobility and urban form. And if we put these two things over a sort of a 2D space, a Morphospace 2, if you will, of possible and viable configurations and human settlements, you have density and you have mobility. And so you need these two things for a city to sort of emerge and a society to keep growing in terms of complexity, okay? That's a hypothesis. You can believe it or not, obviously, and the studies here to sort of examine that. So if you have lots of density like Çatalhöyük, you have very little mobility. That, in this sense, it's very hard to move in the city in a configuration like that. And that's one of the hypotheses archaeologists explain why this settlement was abandoned eventually. And then on the other hand, you have the Bororo village, which is absolutely permeable with lots of allowing lots of mobility there and very low density, all right? Which is clearly not a city. You cannot put 5,000 people in that structure. It's going to be really, really hard to do that. And then you have somewhere in the middle places like Barcelona or New York, like contemporary cities, okay? And then settlements that you can sample and analyze along those lines there. This is a hypothesis. So there's a sort of a region of possible urban form, which is what I'm trying to understand. And if you have too much density, it's not going to work in the city. You cannot move in there. And if you have too much permeability, you have really low density, and that gets in the way too. So there's a region there that we need to understand. And I'm placing this as a sort of a relationship between density, meaning proximity between specialists, and mobility, which is the capacity of moving throughout a spatial configuration. And if these two things increase, as we are likely to need, there's a potential conflict there. So how do cities solve that? How urbanization solves that potential conflict? That's a key question. So ultimately, density and mobility can be contradictory properties. How can we solve such a it is a spatial problem, right? So densities alone won't do. Densities can be messy. We can achieve density in an endless way, and most of them has no structure. Things like that. So I'm proposing to explore permeability as part of this spatial solution. So what we need is a sort of a kind of configuration that allow density and mobility at the same time. So we need to achieve that this mobility through permeability between buildings. So, this places further issues, further problems we have to solve, you know, in order to understand this. Permeability is also not enough, because we can have arrangements very permeable, but still really difficult to live in, like a labyrinth. Okay, you clearly have permeability there, but it's really hard to move and understand it. So these places are not actually produced by human beings unless you make a real effort to try and create one. It's not easy at all. We are not wired to create cities like labyrinths. Even favelas in Brazil are not labyrinths. People think they are, but they are not. They do have a lot of structure, okay? So we need some form of structure there. And then I bring now Hilliard and Hansen idea of restrictions on random processes as a reason for the emergence of microstructures and structures across scales. Okay, of course, you need to explain the whole process, and I don't think these experiments there explain it apart from the local scale. But of course, Hilliard made a huge effort along his life to understand that, and the whole theory of space syntax does that. So, but I'm approaching built form here, as you can see, and its relationship to open spaces. So there's this sort of an experiment there where you need to reduce or restrict randomness, or reduce, as physicists would have it, reduce entropy. And what is happening right now here is we are reducing the chaos in that distribution, the randomness, and going into a sort of a more predictable structure, if you will. Okay, this is going to be the same number of cells, by the way, and it's sort of finding more repetition, more consistencies, if you will, and it ends up with something like this. That can go anywhere. That simulation can go anywhere. But this is one of the possible final distributions. And you have a reduction of entropy like that curve over there. So that's the direction I'm going. We need some kind of structuration for an urban settlement to survive. So entropy from physics means it's an issue of predictability and probability. So entropy does not equal, you know, randomness in terms of chaos or lack of order. It's more than that. It has to do with a probabilistic thing. In a place like this, in a distribution like this, you have high entropy because it's very hard to predict where the next cell is going to pop up. It can be anywhere. This curve, this distribution curve here, they don't show you much in terms of making you able to predict where the next cell is going to emerge. Whereas if you have something like this, you have a probability curve there, which indicates that it's highly likely that the next cell is going to emerge somewhere, more likely over here than over here, let's say, even though it's still possible. So low entropy structures. Bringing this to cities, you have Tokyo with high entropy, and we actually can measure this, and we did in a recent paper. And then we have Chicago, very low entropy. And you can see, I mean, you can sort of, you know, intuitively grasp the idea of all these micro variations here, amazing variations, whereas here you have very, you know, aligned pixels, if you will, facades. So you have much more consistency and predictability on the right than on the left. And that's the concept of entropy. That's why it's useful. You can describe an urban form exploring the idea of entropy and the idea of information. I'm not going to go into details over this, but information in spatial terms, I'm dealing as the opposite of entropy. This goes against Shannon, who sort of created the formula of entropy. He thought entropy as information, but from a physicist perspective and from an urbanist perspective, you need information. You grasp information through visual terms. You need to navigate and understand the city around you. So it's probably easier to grasp the structure here than here. In here you can, through a single eyes of this, if you will, a single perspective, it's going to give you a lot of information. You understand the whole from the part. Whereas over here is harder, all right? So information is a way into structures. So the idea is to, you know, understand how human beings, when they urbanize space, they manage to contain entropy, not get rid of it, because we can't. when it's not, it's not a problem. I'm not equalizing entropy and something bad, okay? I'm just saying that it needs to be managed. So essentially, we need a kind of structure that allows density, allows mobility and permeability through buildings, okay? Or between buildings. So we need to put together these three properties, that's my proposition, in Morphospace. And we can measure them. Again, here are, for some reason, this is not properly working, but there are three measures. You can, the paper brings the measures. Apologies, the slide didn't quite work. And the method basically deals with Nolli maps. So you reduce 3D urban form into Nolli maps, and then you have them as a raster distribution, and you can calculate permeability using urban blocks like this representation here. You can calculate information through the building footprint map, doing something like this. You essentially count frequencies of configurations. This is one configuration among hundreds and hundreds possible configurations. You count them, and in a place like Washington, you have lots of these configurations. This configuration right there, you have lots of them. Okay. Whereas in a city like Lagos, in Nigeria, you still find it, but less frequently so. So this structure here is more predictable in some ways than this one. That's how we are measuring information and entropy here. So going out to the empirical studies and the final part of my presentation, we have a sample of cities that you can see all over the world. We threw in the as I mentioned earlier, and some Maya proto-urban settlements, which are low density, but still have some, they still have some really interesting, alignments between those facades there. And then we threw in also some theoretical cases there, like random and tree-like and highly ordered structure. And so this is our sample, and this is our cube, okay? Our cube has this three axes: information, permeability, and density. And now we apply those three measures, which I couldn't show you, but trust me, they are in the paper, so you can. So we apply those measures to this sample, and each city gave us a different value for each property you have there. And this is how they look. So you have there the intensity levels, the more red they are, and up in the cube, the stronger the higher the value of these properties. And going into these different cities now, we have, for instance, the theoretical distributions there, the order and the random configuration, and then you also have the Bororo there, and you have Satao-Ryuk over there, as you can see. And you have some cities like Beijing with very low entropy. Due to 800 years of planning, they controlled pretty much. So this is our lowest entropy city that we can manage to find. And you have Lagos, which you can see there, very, lots of change, constant change across the distributions. So, and Washington you have over there as well. And one interesting thing here is that we have the sort of a well-defined regions there. We have the theoretical configurations are in clear positions. You have the proto-urban Maya and distributions in the yellow circle, and then you have cities sort of clustered there. So that's one interesting thing that the cube was able to grasp. So this morphospace seems to distinguish between theoretical configurations, not settlements, occupy specific regions within the cube. So that's an interesting finding. This perspective here allows us to see something also interesting, which is how cities they behave, within a sort of a small range of information. Beijing is a bit of an outlier because it's pretty much controlled, but still, of course, much less than a perfectly ordered configuration. And here we have the completely random, the most random distribution we were managed to generate, and we try to do that. We try to find the most random configuration. So these are some findings, and the idea of you see there this sort of a you know, a very small, you know, range of information here, and most cities are within it. And there you have the non-urban settlements there, and the theoretical configurations there. So the question is, why do most cities not occupy positions below or above that level? Again, this is density. Sorry. There you go. So you also have a sort of a very narrow, or not very narrow, but narrow enough, you know, concentration of cities there. Berlin is again a bit of an outlier, and along with Buenos Aires, but most cities are within that region. So we have some regions within the cube which are not explored by humans. So why are there no settlements in these regions? And are these impossible positions for cities, meaning these are impossible values of permeability and information and density? So some questions that are left. My final slide here, the hypothesis that settlements evolve through morphospace to reach and balance certain levels of density, permeability, and information in order to be cities. Well, the data does not allow us to reject the hypothesis at this stage. So that's where we are. And essentially now I mean, the next steps, we have to understand how exactly the process of formation, right, of these structures, and how humans shape, you know, create these distributions in a way to control entropy and increase information, and that sort of, and increase permeability while increasing density. It's a tough balance there, and we managed to do it in different regions of the world and different times. So that's it. So thank you.
Good morning, everybody. I will be presenting my current PhD research, which focuses on methods that promote co-learning between research and practice in planning, and focuses on addressing the physical form of cities to contextualize this topic. And so it's long going in research that material being produced in research isn't really being applied in architecture and planning practice. And so what this project proposes is to find a way to connect all of these studies on this gap between research and practice, and finding new perspectives on existing tools to promote co-learning and collaboration. And here the focus is really on promoting continuous interaction and multi-directional exchanges of knowledge. And for this, it's necessary to have an active engagement of actors. And in turn, this presupposes a multitude of opportunities to interact between researchers and practitioners. And so this is what this method does. And it does so by dividing itself in 3 different stages. A first stage that uses communication to understand the bigger paradigm in planning systems and administrative systems. A second stage that uses observation to understand concrete processes in planning practice. And a final stage, collaboration, that uses collaboration to understand specific thought processes. And so in this presentation, I'll be presenting each one of these stages and some preliminary results from their application in a specific case study. And so in this first stage, semi-structured interviews were used to understand this bigger paradigm in planning practice. And so it searched for answers from practitioners and academic consultants on the difficulties of practice, potential solutions to these difficulties, how much the academy can interact with planning practice, and the conception and use of urban form and urban morphology in practice to contextualize this topic. And the idea was to gain a great range of responses to these topics. And so the Porto's metropolitan area was selected as a case study for this stage. And we targeted positions in different municipalities that were responsible for teams in planning and development control as the implementation of planning. So this resulted in interviews with 16 municipalities, multiple people that also integrated some team members in some cases to participate in these interviews. And again, we talked to 5 academic planning consultants to provide this academic perspective in comparison with a practical perspective. These interviews then inform a literature review, which tried to understand how this context of Porto's metropolitan area then could compare to other contexts and other more encompassing theories. And we also sought for other topics that could be relevant to inform this research. And so the results from these interviews, at first, practitioners were very clear that they feel there's an excess of regulations that restricts the available time to explore other forms and other methods to interact with urban form in planning, namely those from research. We also find that there's a different perspective in how to view urban form and urban morphology. And in practice, this view is often much more numerical. And so they focus more on the quantitative indicators and not necessarily on the theories behind these quantitative indicators and how urban morphology can be used as a strategic way of thinking the territory. We also find some potential ways to introduce research on urban form, firstly through non-binding studies, like, for example, using space syntax to determine where to potentially place a bridge, or using regulatory plans. And here, in these regulatory plans, consultants informed us that there are some potential barriers, namely different scales require different things from urban form and urban morphology. So neighborhood scale plans might focus more on design, but more regional plans might need more strategic guidelines. But because there is this different perspective of what urban form can be, this more numerical perspective in practice, and this more strategic view in research, there can sometimes be some barriers to integrating research on urban form in these different scales. The literature review also provides us with some important points to consider when engaging in this plan development, namely the importance of having support, both politically and technically, and the importance of translating the relevance of certain concepts of research to urban dynamics. It's important to transverse from one side to the other. Also important to promote achievable goals, technically and financially, and using language that can be accessible, not just for the team that is currently producing the plan with us, but for any other team that might come in the future. This first stage also showed that there are some frequent modes to integrate research on urban form in planning practice currently being used in Porto's metropolitan area. And these different methods could be used cumulatively, and this joint use identifies then different types of municipalities, some that use all of these methods, and in one case, one that does not use any of these methods. And so from this, we found examples of each of these types that also could represent the great scope of Porto's metropolitan area in terms of social density, of residents, of artificial land built, of financial balance. So it's very diverse in this gender. And these municipalities were selected to inform the following stages of this method. And so the second stage uses observation tools to then understand specific processes in planning practice. And it then analyzes documents that regulate ongoing projects. It observes in real time tasks that practitioners in municipalities are developing, asks informal questions of these practitioners, and notates all of these information to then inform future questions. The focus of these observations was to understand the processes behind each project, understand how and why research and academic knowledge were being used, and then understand how urban form and urban morphology are understood in these processes. And so for this, we selected 3 case studies: Porto, Espinho, and Valdecambra, which represent types 2, 3, and 4, which do not use all of the available methods found to bridge research and practice in Porto's metropolitan area. This experience highlighted some potential within existing processes, namely all plan development starts with an initial territorial analysis, and this provides us some space to integrate research on urban form because it focuses on some spatial topics. You also find that architects tend to have notions of urban form that more closely resemble those of urban morphologists, and so this could be a potential bridge for easier communication. However, there are some barriers, namely in this territorial analysis, because they are mostly focused on buildings and not other elements of urban form. And so analysis of urban form at neighborhood scale are usually more recognizable as analysis of urban form, and usually are more recognizable as such by architects and not necessarily other practitioners from other study areas. Additionally, more dispersed territories can have some difficulty in integrating research on urban form. As a very simple example, usually when we refer to blocks, we refer to blocks as defined in very dense cities. And sometimes more dispersed territories have some difficulty in identifying that in their own territories, and so have some difficulty in integrating research on urban form on that topic. Finally, the last stage works a bit like a consulting service. So we work alongside a municipal team in this case in the planning division, and provide some applied research to a specific topic. Here, because it's very dependent on current needs, it's important here to provide a brief presentation of this case study, which was Matosinhos, which is the only municipality found in Porto's metropolitan area to use all of the methods to bridge research and practice. And this is a municipality that had previous consulting experiences with academics, and the chief of the planning division is an academic. So it also facilitated that contact. They were at the moment developing a method to systematically and scientifically address urban areas available for consolidation, which is a specific concept of this municipality that describes large open areas to be developed located between consolidated urban areas. And so they were trying to find indicators to inform the future layout of these areas, these audacs. And they wanted indicators that considered morphological integration and also socioeconomic conditions that layout would provide. Considering these necessities, the research team, we propose a specific method, which is Morpho, which identifies quantitative measures that assess the current urban form. And through this assessment, we can then describe the existing form, evaluate the impact of changes over that form, and also examine the correlation between that form and socioeconomic and environmental performance. And so for the specific case of Matosinhos, within the list of indicators that Morpho proposes, we find that 3 indicators were of particular importance. So these were the number of four intersections because of their correlation to higher accessibility, the density of plots because of their correlation to socioeconomic diversity, and the coincidence between building facades and plot frontages because of their correlation to street definition and dynamics. And so to apply Morpho in this particular case of the AUDAX, we used two different approaches. During the first approach, the research team proposed a new layout that was based on these indicators that I just mentioned. And so the idea was to compare the layout from the research team with the previous proposal from the team of the municipality and compare the existence of these indicators and what were the potential outcomes in terms of socioeconomic and environmental performance. During this approach, each step, so while we designing the streets, the plots, the buildings, each of these steps were presented to the team to not only for them to understand our rationale, but also for us to understand what barriers they were finding in our rationale. And then we had a second approach where one researcher and one practitioner were seated side by side discussing a third new potential layout. And so each decision, each thought process was shared between both actors. And in the end, all of the decisions were understood by both sides. And so again, here you find some topics important from these applications. First, we find that financial and administrative topics were informing the final design. So particularly practitioners with which had previous experience in this type of projects were doing were taking some decisions that took into account these financial and bureaucratic barriers. And so, for example, reducing the number of streets to reduce the cost of infrastructure, or reducing plots to promote larger development projects, because they knew that this would be accepted and could be advanced. Then we find that there are some subjectivity in practitioners that also inform some design decisions. For example, when we researchers were proposing narrower streets or smaller plots or different activities in the building's ground floor, we found that some subjective interests and aspirations from the practitioners would maybe deter some of these decisions. They wouldn't support us as much as if there weren't any presupposed subjectivity from their part. And finally, we found some regulatory barriers. So particularly in the discussion when we were working side by side in the second approach, we found that when quantitative measures are used to define large portions of the territory, in this case, building height and construction capacity are used to regulate large portions of the municipality, areas such as the AUDAC find more difficulty in proposing compact urban forms in their new layouts. And so specifically here, we find that these specific regulations were hindering a higher density of plots and positioning the building's facades to be coincident with plot frontages. And so what we find from this entire experience is that firstly, we need to, again, call attention to the rationale behind quantitative measures and invert the tendency to view urban form and urban morphology only per their numeral dimension. If we do this, we can call attention to the potential of strategic thinking that urban form and urban morphology can propose. We also find that it's important to go beyond buildings and address the relevance of other elements of urban form, like street blocks and plots, because these do inform the longevity of urban form. And it's important to highlight their potential, and also through this underscoring this potential, we can also underscore the potential of some research on urban form to inform of these elements. We also find that this apparently simple transition from quantitative indicators to rationale, to possible urban layouts, and then finally to socioeconomic results needs to be very clear in these discussions. It seems obvious, but it's also during these experiences, we find that sometimes some of these steps get lost. And by losing these steps, this is when communication between both parts becomes more difficult. And so it's very important to understand what are the best ways to make sure that this transition becomes very clear. And this will be one of the major focuses on the future of research of this ongoing project. Finally, throughout all of this, what becomes also very clear is that without the support from the chiefs of departments and planning divisions, this research would not be possible. And so we really need to understand how can we find the support in a systematic way, in an institutional way, so that these type of experiences aren't restricted to just PhD projects, and can be implemented in several other projects and several other editions. And that last slide is missing, but is my presentation. Thank you.
Hi to everyone. Okay. This presentation is part of a broader research work that intends to measure the impact that an urban form adapted to topography can have on mobility. And contrary to the literature, this research work starts from the hypothesis that there are other features with other morphological characteristics with energy relevance in addition to slope, resulting from this relationship between urban form and topography. These other characteristics can be, for example, the proportion of street sections, the density of intersections, changes of direction, and the consequent reduction of sight distance, as well as interactions with the buildings and urban activities. These morphological features can limit the speed and access of cars. To test these hypotheses, two complementary methods are developed. The first one is a new scoring tool that can be applied route by route in any city. The other one is a GIS-based simulation addressing large urban areas to have a higher volume of analysis. That is the focus of this presentation. A literature review in the field of traffic engineering makes it possible to identify a set of built environment factors that influence speed of cars and pedestrians. From there, 7 structural variables of urban form, such as street width, number of direction changes, number of intersections, slope, curve radius, number of plots, and the number of plots without access to cars, and to variables with impact on pedestrians, slope and number of intersections are defined. Some of these variables, as many as possible, are used in this simulation. For this, it was used a database. This is the global urban street networks. It's the best I found, open source, gathering the street networks from thousands of urban areas around the world, using boundaries from the global human settlement layer and data from OpenStreetMap. It was used the open source GIS software, GIS, for database editing and ArcGIS to calculate routes with network analyst extension. Two case studies are chosen for this simulation, which are Salvador, Bahia, as an example of an organic urban form, and San Francisco, which is a good example of the opposite, of non-adaptiveness according to specific morphological criteria previously defined, but it's not the focus here. These two cities are chosen because among the few available options, they are two large cities, allowing for a great volume of analysis, taking advantage of this simulation. The street networks contained in this database are available in GeoPackage format. So each GeoPackage file has two layers, one of edges, another of nodes, and also an altimetric dimension to each edge. Yet urban form is not only streets. For this reason, a layer of buildings in QGIS is added to the layers of edges and nodes to match as much as possible the defined variables I said. To have a comparable basis to this analysis and to quantify the intended variables, there is the need to consider the same area of analysis in both cities. So this a frame of 5 to 5 kilometers was used with the same criteria, covering as much as urbanized area as possible with the maximum expressiveness of the intended morphological characteristics. All the previous layers are clipped by this frame that limits the area of analysis. And Salvador and San Francisco are represented by three layers corresponding to the data available. Sorry, it is okay. So there are variables that can be encoded in the networks, such as slope and number of buildings adjacent to the street, which are introduced in the attribute table of each segment. The slope information is already in the database, while the number of buildings is added to the attribute table. Other variables are not codified in the networks. Rather, they are considered later through the calculation procedure, as they are dependent on the chosen route. These include the number of intersections, plus possible changes of direction, and the sinuosity of the routes through a plugin that can be measured through a plugin to the QGIS. They are the only 4 variables considered among the 7 variables I presented before. It's the possible, because this simulation it has some limitations. All methods have limitations. So regarding the simulation variables encoded directly in the network, it is important to highlight that pedestrian mobility as the slope as the only variable for modeling purposes. It is adopted the Tobler's eking method to determine the average speed as a function of slope with this formula. To consider all the possible routes in the networks under analysis, each route is calculated in both directions. So with a positive slope and a negative slope. So it is calculated the average of both. In car mobility, the same slope affects speed, starting from an average speed of 30 kilometers, and based on the graphs in the literature to determine this table of speed ratios from a level terrain. Based on this table about the effect of slope on car speed, a polynomial regression curve is calculated with adjustment at 0, obtaining the following formula. This gradient that explains 99% of the variation, so the adjustment is good, I guess. But this regression does not consider excessive slope values, as the curve changes drastically. So there is a need to consider for these specific cases a simplification of values. That is not here, but it's only in specific cases. As with the pedestrian calculations, the speed of each section is calculated by the average between positive and negative slope. Again, but the average speed is also penalized by the number of buildings encoded in the networks, car speed. Applying a penalty ratio that is multiplied by the base vehicle of 30 kilometers per hour. As there is no support in the literature for this relationship, a proprietary scale is used that is there. And as a result, speed in each network segments result from the combining the impact of slope and the building density multiplied by the base speed and by the slope average and the penalty ratio due to the number of adjacent buildings as described below. The slope also affects car energy expenditure to a ratio comparatively to the expenditure corresponding to the segment level. The same process used in car speed is used here. Again, the formula of the regression curve and the average between the positive and negative slope. The calculation of routes with the network and analysts requires the formation of a grid superimposed on the networks of each city, from which the centroid of each cell is determined. In this simulation, a spacing of 2,000 meters was used. So it was the distance possible, considering also the calculation capacity of the software. And the paths are determined between each pair of centroids, generating an origin-destination matrix. In this calculation of routes, the other two variables I mentioned before are codified in the data are not codified in the networks, are considered here. The density of intersections and the sinuosity of the routes that is calculated through the ratio between the real distance and the distance in a straight line between each origin and destination. According to the software presettings, these work calculations are all done to minimize time or energy expenditure. In the pedestrian mobility, the fastest route for each origin destination pair is calculated. In car mobility, for each possible origin destination combination, the fastest routes and routes with less energy expenditure are calculated. Here we have the results of this calculation, and before the results itself, it's important to summarize some indicators directly from the networks. The average pedestrian speed is practically identical. The average car speed is a bit lower in Salvador, and the slope, the average slope is practically the same in both cities. Regarding the the results, they are average values, and they show differences between Salvador and San Francisco. The table has units, absolute values, but the relative differences are more important. So the pedestrian travel time in Salvador is 18% higher than in San Francisco. Car travel time in Salvador is 23% higher than in San Francisco. And the average pedestrian speed in the Salvador network is 2% lower than in San Francisco. And the average car speed in the Salvador network is 80% lower compared to that of San Francisco. So the results show that the travel times in Salvador are always longer than in San Francisco in all calculation processes, both because the speeds are lower and distances are longer in Salvador, as can be seen from the higher sinuosity averages. However, the difference in cars travel time is higher than the difference in pedestrian travel time by 5%, and the difference in car speed is also higher than the difference in pedestrian speed, 6%. So the average pedestrian speed is practically the same in both cities. The effect of adapting urban form to topography is understood both on speed and distance, which are determinants of travel time. It is also evident that this effect is due to the urban form as a whole and not only due to the slope, that in this case has practically the same value. Therefore, cars are more penalized in Salvador than in San Francisco. Car energy expenditure is also always higher in Salvador than in San Francisco, which reinforces the results. As the conclusions, can say that the results of this simulation are in line with the research hypothesis. It's important to consider that this application to the Salvador and San Francisco is just a test. More applications to the networks of other cities are needed. This approach, it shows that the role of topography as a natural resource can be well used by urban form, and on the other hand, it contributes to the production of evidence on this fundamental dimension, which is the natural physical support that was forgotten from the research in the urban field. Thank you.
Sim, peço desculpa. Já está.
Sim, já está.
Já está a funcionar? Sim? Okay. Sim. Sorry, I have my note here, but it's important now. Try to understand if anyone wants to ask questions about this article, but I think that all three speeches are very interesting, and and there is a number of questions. Yeah, and they provide clues for further research. I think. I don't know. They are very different. But before pass the word of the public, I have some question for you. I'm curious about. Sorry, the name. Your name. Vinicius. Yeah, the Deciphering urban morphogenesis and morphospace perspective. There is, sorry, there is a point in your study relating to growth in search of structure, I think, where the approach adapted seeks to challenge the notion of random or purely ergodic urban development. The point is, as you state in your work, cities self-organize through feedback mechanism and adaptive growth, producing configuration that are not necessarily the most suitable, but which are adequate enough to support mobility and interaction. Does this mean that planning has never been effective or adequate enough to guide and accompany urban development and transformation? Another question is that, sorry, but I'm curious. Are the special innovation that you speak the result of planning contribution, or are they mainly the result of unplanned situation? This is for you. This is the first, but I can say about Anna, yeah. Regarding this paper, I would like to make just a few comments. This topic very interesting because I write many questions about this. It's yeah, it's very important. If it's not a question, it's not a reflection. If it's true that in planning practice there is a need for a certain pragmatism to respond to the countless and complex demand of the transformation and construction of the city and territory, it is also true that the academic perspective can contribute and establish a more effective relationship with the practice, producing applicable knowledge and of the practical dimension, the production of applicable knowledge through methodologies used in academic research has not always been used to guide and improve the operational and regulatory elements of planning and design. An example of this in Portugal are the last generation plans, where the elements of the proposal do not translate or report, even in the form of recommendation, much of the information produced in urban planning studies and various thematic characterization studies. If the one hand, this type of situation could be related to certain planning option. For example, simplifying the zoning proposal to make it more flexible. On the other hand, it seemed to indicate a lack of new intervention methodologies capable of adequately utilizing the information produced during the planning process. This is, it's complicated. About the last intervention, it's more a reflection. It's about the question, it's possibly one of comfort. I think, I don't know, because I think very interesting the possibility, you know. But I don't know, it's something, the penalty for traveling time may be either for cars, but the factors of comfort and convenience may be decisive in the choice of mode of transport. However, I think that the quality, comfort, and safety of the public space may also be decisive as a factors that could help to promote and encourage pedestrian mobility. Okay, so it's so. If Katerina, yes.
For me, it's definitely better with the microphone. Did you encounter when you were working with Matosinhos Municipality any situation where Festus? Did you encounter any situation where, because you talked about how it was not only the quantitative results and research results that were taken into account by technicians at the municipality, but also previous knowledge that they had about bureaucracy and well, the things that had to comply to regulations and norms. Was there ever any at any moment where sorry, where the research that the work that you did in collaboration with the technicians was thought to be used as a means to argue for different proposals, like argue for a solution that both technicians and researchers knew was best, was better than what is usually passed, but is not what is usually done, and so goes against what we know is going to be approved or not. Because this comes from personal experience with some of us in the organization. I've worked on a consulting project with the municipality of Porto, where we did some analysis of how people use public space as pedestrians, and then equip them with tools and methods to use in future projects. And recently, one of the technicians contacted us for help as to, we know this is the right thing to do in this situation, and how can we show the people who approve our projects that this is the right thing to do? So did we encounter a situation like this?
So thank you for both your questions and reflections. Maybe I'll answer them in order. I would say that yes, it's without a doubt a need for pragmatism that kind of forces the relationship between research and practice to be as it is right now. And I would say it's on both sides, because as researchers, we also have a set of things we have to accomplish, a set of things that we need to produce, and timings, especially timings, are very different in academia and practice, and this can very often hinder a relationship between them both. I would say that what would really contribute here is, at this point of my research, I would say that what would really contribute here is a systematic institutional support, something that can give the municipality some time to just turn off a bit eyes from the regulation and turn a bit to other options, and then they can speak to us researchers to help them with that. And it needs to come in strong networks that allowed for researchers to more easily contact municipalities. This doesn't always need to be a consulting service. This doesn't always need to be a research project. There are other options for communication that exist in other countries, and we aren't currently applying them now here. And I think that with that institutional support, this communication would be much easier, and it would be much easier to intervene in certain things like the regulations that the more recent regulations that you mentioned. And right now, my my hunch, my very informed hunch from my research is on this topic, but of course that more time is needed to see how this could possibly be applied. In response to your question, I would say that in that situation with Matosinhos, um, it it was clear that some of the ideas that we were proposing, they also had them, but weren't able to apply them because of these financial restrictions or regulatory or administrative restrictions. And what we found is that through this communication, this very close communication, sometimes it's really necessary to just sit side by side and talk it out. Sometimes it just needs that time. And sometimes that's the more difficult thing to get. It's the time. And what we find is that when we start pointing out, okay, we want to do this because of this. Okay, we agree with this, but we can't because of that. And when we start taking apart that doesn't allow us to continue, this is when we can find what's the regulation that's stopping us, what's the financial hurdle, sorry, that is stopping us. And through this conversation, it's easier to find other ways around. Not always. In the case of Matosinhos, there were things that in both approaches there were different results, of course, but there were things that we came to understand that, okay, we will not be able to advance with what we want in the research team. We need to circumvent this. And there were other times where practitioners were like, no, wait, we can take this, we can make this in another way. We can turn this around, and if he just change a few things here, maybe we can introduce some new things. And but really, for both things, it's time here is of the essence. We need to be able, the municipalities need to have the support for technicians to just take time and search for other methods, talk to different people, and experiment with different options.
I just want to add two topics to this reflection that Anna was mentioning about Katerina's question. Sometimes we call it the washing machine there in the division because of the pressure on time and the new regulations that are coming out from the government. They are stressing the response period that we have to give to a certain urbanistic operation. So time is really difficult to incorporate the time for research, for instance. That is one topic. The other one is to change change the culture of the technicians, because I have technicians there working in about 30 years in the same place, doing the same thing. So the mindset for how they do things, they are quite established. Why? Because with that mindset, they respond quite fast enough to the shortest period of time to the thing they have to respond in formally. So the washing machine starts there. You put the on button going on, and then the mindset is already processing a certain kind of way to respond to that period. And the third topic is a stakeholder that is not in this equation, that are the promoters. Because, for instance, I will give you a very short example. One of the things that Anna introduced to us was the importance of the plot with a neighborhood configuration, with a close one, with like a Barcelona plot. We explore a lot the isolate building. Why? Because for that, for owners, for promoters, to engage with solutions that have to be related with other owners of plots within a certain area, it is easier for them to be more autonomous than to do sort of a Barcelona plot, if you want. So owners and promoters, they also are more tend to go through isolated building solutions than the one from you were suggesting as a neighborhood plot, for instance, a Barcelona neighborhood, something like that. So stakeholders, they also have here a word and their times also, and their the need for a quick response there. but nevertheless, the change is possible if it is demonstrated. One of the things that we use is to tell the promoters how the better solution they will get will improve the money they will get when selling it. If you come with that kind of argument, they are able to listen and to give us a chance to go to that track. But mainly what you said about the time, the difference between the time of research and the legal time that we have to respond to these sort of things.
So yeah. First of all, full disclosure, I know Vinny's work and I like it. So I've got a question. Yeah, well, you know that. You showed like a flattened configurational analysis. In the end, you said that you do figure ground and you take the 3D and you flatten it down to 2D. So out of pretty much curiosity and because my work is a bit relevant to yours, as you know, what did you test 3D and what were the problems and what was your kind of course, like in a sentence, your gut feeling in why you didn't or why you will or whether you've done other experiments? Well, of course, I really like your work, you know that.
Thank you for both questions. Your questions are also more than one. So let me try and address them quickly. Let me start from the end. So I mean the reduction from 3D distributions and structures, which of course we live in, to 2D distributions. Well, first of all, it's a sort of probably has to do with a lot with data available. Also going from trying to be as simple as we can, as basic as we can. I work with a couple of physicists, and these guys that how these guys. I mean, they operate always on this method. Yeah, you go for the most simple thing, and then you build up from there. So that's the method, a way to get it started. Of course, your question implies, obviously, that there are a lot of information on the third dimension, which we need to take into account, and we do. And we haven't so far in this particular work. Well, because of data, also computing power, we are limited to in order to process those maps. We're getting better at that with better programming, but it's still, time consuming in that way. But and there is something. The third reason is the fact that when in a previous work we analyzed 3D variation, and compared with 2D variations in spatial arrangements. And if I mean, what came up from that small sample, to be sure, so it's not sufficient as an answer to you, but what appeared to us is that the level of information you have on 3D and 2D for the same sample of cities becomes kind of similar. So a complicated city in 3D is also complicated in 2D, not on a linear, absolutely perfect way. But for instance, if you get Manhattan, you have a lot of variation in height, right? In buildings, you probably have less variation on the 2D level, but still you have some variation which has some resemblance. Other cities like Barcelona or Rio de Janeiro or São Paulo, you have so much variation in those cities. Brazilian cities are so complicated in 3D, and it shows in 2D. Barcelona, it's very sort of organized, particularly the area from Cerdà's plan, it's very controlled in 3D and also in the third dimension and on 2 dimensions on the ground. So there is a correlation there. So what I'm saying is that if you can explain a city from the sort of a most basic information sufficiently, you should be all right. But we need to demonstrate that, and we haven't so far. So your question is obviously irrelevant. So, and your tough questions there. The growth in, it is urban growth or growth in search of structure. You got it absolutely right. And humans sort of challenge the ergodic development. Ergodic, what does that mean? Ergodic is a concept from physics, which means you try, it means a behavior that tries every single possibility. For instance, at the level of atoms, if you will, atoms glue to each other in every possibility in order to build molecules and so on and so forth. But that doesn't happen above the level of molecules, as Stuart Kaufman puts it. So humans will not do that. We will not try every single possible configuration. It would take us billions of trillions of years, and our minds don't need to do that. We sort of infer that's we probably infer that, and we probably try different configurations, and then if they don't work, like Chateaubriand at some stage that stop working for you, then you have to change it and try something else and try and so it's sort of a trial and error process probably. This is all it requires archaeological studies, okay? But Alexander would explain that in that way that yeah, it's trial and error and adaptation. So it's a Darwinian process, if you will, but with the difference that humans can infer and can, once we find something, a spatial innovation that works, we are likely to reproduce it. And then we render it into a tradition and a spatial culture. And then it becomes, if it works well enough, sufficiently, you keep on going. And then that might explain why some cities, some spatial cultures, like my own Brazilian spatial culture, you have complicated cities there. The workings are difficult. Mobility is tough in Rio, in São Paulo, most cities in Brazil, big cities. But still sufficiently for our local societies to work, even though if it's not as efficiently or energetically sustainable or and all of that, still sort of works. But then enters planning, as you asked. Planning helps us to fix problems and identify problems and fix them through theory and all of that. So, yeah.
Okay. It's just 2 fast questions. Okay. Nuno didn't answer yet. But I have a question also for Nuno, and one for Vinicius. You have developed this approach to understand urban form or some parameters of urban form. What I would like to know if in this research there is any idea that can help planning, okay, become some way a form, I don't know, generative, probably too much, but at least some parameters that can help us in urban planning. For Nuno, is more technical, which is how you obtain topography information and how did you calculate slope in this method?
Thank you. Very quickly. Well, you got that, that right. This is sort of a basic research, right? Sort of a fundamental research trying to understand how things, happen and change. And how can this be applied to planning? It's a challenge, probably a bit of a long way. But not perhaps this research as a whole, but parts of it, like the entropy part, like the calculation or analysis of entropy in urban structures. We have been doing that, and for instance, we identified that, yeah, as I mentioned, Brazilian cities are really high entropy, for instance, in comparison with American cities, let's say, which have much lower entropy. So some aspects of this analysis, like if you apply those measures and you try to understand what are the let's say, the hotspots in terms of problematic areas, like too entropic areas, or perhaps or not permeable enough. So what I can envision right now is, yeah, I can pick parts of this analysis and apply them to contemporary cities and give support to planning. That's what I can reply.
Thank you. So our calculated slope in this method, it was very easy because the database used already has an altimetric dimension, so it was very easy to calculate the average slope in both networks. And the other I'm considered topography. Well, topography was considered according specific morphological criteria regarding streets, plots, and buildings. It was not showed here in this presentation, but this morphological criteria was very important to select the cities and how to consider if a city is really well adapted to topography or not. According to this criteria, it was built a sample of 32 cities, and then these two cities, Salvador and San Francisco, were selected because they are really big cities to use this method of the GIS simulation. Regarding your question, indeed, the quality of comfort and safety are very important to promote pedestrian mobility. Well, there are a lot of factors, and all the public space in general is very important to promote pedestrian activity. Here, I just showed the effect of this morphological characteristic, which is the relationship between urban form and topography, and the effect on the competitiveness between car and pedestrian. The reality is always very complex, so we need to choose what we want to study, and then we need to use models to approach, and the model is always a simplification of reality, and then we go step by step, going close to the truth. But if we consider the safety, let me say that the traffic calming measures that are usually applied in the public space, they don't work in many cases. At least with me as a driver, it doesn't work. I drive always much faster than there are not authorities here, I hope. So okay. It's dangerous. At least with me, it doesn't work. To paint 30 kilometers in the pavement in the road area, or to use this plastic, I mean, it doesn't work. No, I mean, what I'm the message that I wanted to show here is that this relationship between urban form and topography it can work as a structural traffic calming solution, much more efficient than these traffic calming measures. If we think you can drive faster in the village of Sintra, or in Óbidos, or in Marvão, or in the center of Évora. Why? You cannot see what is happening 30 meters in front of you, so you need to drive very very slow, because it's impossible. More than that, this kind of urban form, it promotes a specific urban identity, much more in the city of Porto has everything, but in the city center, yes. So it's all an urban identity that is much more friendly to pedestrians than to cars. But we can think, okay, but this research is not useful, because each city has its own urban form. It already exists, and you cannot change it. It's not true. If we think in Portugal, and Portugal is the worst example to change regarding the changing things, because everything is quite slow, and the public administration is not efficient, and a lot of things. But if we think in the last 50 years, the urban form of the cities, the Portuguese cities, changed a lot. Changed a lot. It not changed well in general, what is a different thing, but it changed a lot, and keeps changing. And and right now in the world, there are more or less 20 cities being projected from the zero. 20 new cities. They are not in Europe or United States, in Africa, Asia, South America, but there are not new cities being projected, and so I think it's important to consider this image.
Well, thank you very much. And I would like, in your person, to congratulate Professor Vítor Oliveira, that is a long-time partner of this symposium, and represents some of the research that is made in the Faculty of Engineering of the Porto University. Well, a very sound research on many aspects, and I would like to make this appointment. Regarding what Anna said, I think all of we know that the city is not made by researchers. There are many stakeholders, mainly I think the main influence, at least in the cities we know here, it's made by real estate. So it's not very easy to influence the development with our research, but it really influences the development. And well, I'm not going to develop on this. Well, I don't know if all the participants here know, but Porto has a plan that is the only I know that is the the absolutely sure and right plan. There is nothing the plan that is not accomplished in the real city. That the reason is very easy to understand, because first something is made in the city and then it reflects on the plan. So no mistake is possible. Maybe you may not believe, but for example, the metro network first was made, and this is a structural definition of the city. First was made, and then passed some years appeared on the plan. So this is, of course, a demonstration that it's very difficult to deal, to command, to have control on the development of a city. Last, we try. Last, for Vinicius, I appreciated very much what you said. Many questions arise from that. I'm not saying anything, only maybe one, not recommendation, one suggestion. It's to try one other quantity that is energy. I am from the natural sciences, and the concept of energy is the main concept of natural science, of physics, for example, since and the concept of minimization of energy that defines the formal configuration of the world. Since Hamilton and Lagrange in the end of the 19th century, this is completely defined. And well, this concept of energy, well, now is applied in psychology, in biology, and anthropology, and also in architecture. For example, Hillier talks about the energy of the city. This minimization of energy, for example, in structural engineering, something near architecture, is one of the formulations that is very, very used, because the natural configuration of some natural structure obeys this principle of the minimization of energy. And if a structural engineer wants to make the best structure, he is going to see what is the best form to minimize the deformation and strain, stress, energy. So that is my suggestion, because maybe in the concept of energy you may summarize everything. Only example, I saw recently the city of Bologna in Italy. You can see in the center the remains of the Decumanus Maximus, but when the Roman Empire decayed, the development was organic and hexagonal. The hexagonal is demonstrated even by energy reasons that is the best form, the form that organically the city develops in a place there is no obstacles, mountains or rivers or so. So the energy maybe is something that can explain some of your points. Thank you.
I will be just a short note. I didn't mention on the opening session that one of the goals of this symposium this year was to bridge theory and practice. That's why this edition, we wanted to do it here in the House of Order of Architects, because it's the organization that in a way established the practice of architecture and urbanism. I want to say this because I also like Vinicius' work a lot. And when we were defining the municipal housing for charter, we tried to use entropy as a measurement for the capacitation of the territory, because in the housing charter of Matosinhos, we engage the right to the housing, to the right to the city. So we try to engage the entropy measurement in our analysis and to translate it in the housing charter. Nevertheless, one of the questions that they made when we were doing this, I'm working on the planning, and then we have the urban management. The urban management asked me, if you put that there, how do I ask to the promoters whatever to reduce entropy? Because we put in the housing charter, for instance, the influence of equipment areas, green spaces, etc. And then in the urbanistic operations, we can ask for the promoters to give terrains to green areas and to equipments. And that is there. But related to entropy, they ask me, okay, I understand what you are saying. We acknowledge that that is important to the capacitation of the territory, but how do we make it operative in terms of what we can do in the urban management of the territory? So sometimes that is for us to contribute to your question about what does his work can bring to planning. Sometimes it's not only to think about the concept and how to, in terms of methodology, to engage the concept in analysis, but also how to make it operative to the urban management. How do I say to a promoter, to a stakeholder, to a real estate guy, look, entropy is like this, and your role to this will be this. So sometimes the communication thing that Anna was saying, it is also important at this level, at the operative level of the concepts and of the methodology that is out of the research environment. You understand? So we need to make this really simple in terms of communication. Otherwise, it will come from this and live there, because they are not understanding what we are saying. So that is really a challenge also for us. And I'm speaking in both sides of the barrier, as an academic and as a practitioner, how to say these sometimes very complex things in a quite linear way, so they can understand, yes, my role is that, and I will do it. Otherwise, they will say, what you are saying? You understand? So that is the kind of contribution.
Let's close this session. Thank you. And thank you, everybody.